So the amino acid which are holding together in protein by covalent peptide bonds are linkages cementing together. Okay, they are cementing together and which are like acting as adherent. Okay, adherent one amino acid to the other amino acid, right? So when amino group of amino acids combines with the carboxylic group of other amino acid, a peptide bond is formed. That means amino group of one amino acid and carboxyl group of other amino acid, then only an peptide linkage is formed. And peptides containing more than 10 amino acids, they are considered as polypeptide. Okay, if any peptide which is having more than 10 amino acids, such peptide is known as polypeptide. So peptide bond in the picture you see here, amino acid 1, okay, and that means carboxylic group of first amino acid and amino group of second amino acid, carboxylic group of first amino acid, amino group of second amino acid, removal of water molecule, okay, they form carboxyamide linkage, okay, carboxyamide linkage or carbamide linkage, okay, carbamide linkage, okay, that is known as peptide bond. That is known as peptide bond. So what are the functions of peptide bond? So it is usually found in a trans configuration, okay, and the peptide bond is partially like double bond, serving as a double bond type, and the N terminal is like what to say, is like partially positive and O is partially negative, okay, and this amino terminal and carboxy terminal are useful in reading like what I mean shorthand to read the peptides. The amino acids in peptide or protein are represented by 3 letters or 1 letter abbreviation, okay, and this is a chemical shorthand to write the peptide. So if you see this slide, naming of peptides, the amino acid suffix, okay, in, okay, tryptophan, okay, glutamate, okay, or change it to YL, okay, peptidyl, okay, cystenyl, glycinyl, cystenyl, glutamyl. So they are all changed to this in and 8, all they change it to YL, okay. So that means cysteine can be pronounced as cystenyl, glycine can be pronounced as glycinyl, okay, glutamate can be pronounced as glutamyl, okay. So glutamyl, cystenyl, glycine. So here I am giving you the example of glutathione, okay. Glutathione is a tripeptide, okay, that means this glutathione is a tripeptide which is made up of 3 amino acids, and the amino acids is glutamic acid, cysteine and glycine. So here we are naming it as glutamyl, gamma glutamyl cystenyl glycine. So we are adding for a peptide YL, okay. Examples of peptides: dipeptides, tripeptides, pentapeptides, octapeptides, nanopeptides. So like this several examples we can give. So dipeptide, so with the name you can say dipeptide, 2 amino acids which are joined by a peptide bond, and example is aspartame which acts as a sweetening agent. So okay, that's what we are talking in the physical properties of amino acids, okay. Aspartame is a product of aspartic acid, okay, with sweet in taste, and this is the one which is serving as an artificial sweetener and replacing the cane sugar, okay, in making of sweets which has to consumed by diabetic people, okay. And it is composed of 2 amino acids, that's what I said, aspartic acid and phenylalanine. Tripeptide, that means 3 amino acids which are linked by 2 peptide bonds. That example is glutathione, that means it is made up of glutamic acid, cysteine and glycine. And the main important points regarding glutathione, okay, this glutathione involved in absorption of amino acids and protects against the hemolysis of RBC. So this glutathione mainly present in RBC membrane. So what is the shape of the RBC? The shape of the RBC is biconcave. So which allows, this shape allows the RBC to easily pass through the arterioles, okay, and in veins, okay. So what happens if it is square or round? It cannot pass easily when there are like any curved arterioles or veins, okay. This biconcave means easily they can skip in the arterioles, right? So that is the main. So once RBC lost its shape, so that's what sickle cells, okay. So in the sickle cells the shape of RBC will be lost, so they finally they get accumulated in the blood vessels, so they will be degraded, right? So sickle cell is a disease, right? So say if glutathione is not there, okay, RBC definitely lost its shape and functionally it become inactive. In polypeptides, that's what I said. If any peptide containing more than 10 amino acids, that peptide is known as polypeptide. Okay, up to 10 to 50 amino acids. So best example I can give, insulin is a polypeptide. So biologically important peptides. So there are a number of peptides. So one example I have shown here in the slide, that is insulin. Okay, so insulin you can take as one of the best example for polypeptide. Okay, so there are other polypeptides. So glutathione we have already discussed for what purpose we require glutathione. Okay, and other than this, there are nanopeptides are there like oxytocin, vasopressin. Okay, so these are the two nanopeptides. So what is the use of these peptides? Okay, oxytocin for smooth muscle contraction. Okay, for smooth muscle contraction, especially in uterine muscles and in the mammary glands. Okay, for ejection of milk and in smooth labor. Okay, during labor, during the delivery. Okay, that time they used to inject oxytocin. So you might be hearing about the milk production industry, like for cattle they used to inject oxytocin, because what it will do, oxytocin increases milk production, but that is not good for health. Okay, the milk which has been produced by injecting oxytocin, which is not good for health, but the function of oxytocin is smooth muscle contraction. Okay, which is a nanopeptide. And coming to vasopressin, is an antidiuretic hormone, that means retention of water from the glomerulus of kidney. Okay, so that is the significance of vasopressin. So these are the other biological important peptides. And when you are coming to the other aspects of peptides, okay, so gramicidin, vancomycin. Okay, so all these are also peptide in nature, which are antibacterial in activity. So that's all about peptides. Okay, thank you.